Hello. Through Dental TV, digital dentistry is delivered every Monday. I'm with the Good Morning Dental Office, and I am Dr. Chun Se-young. This is the first lecture of digital dentistry. First, digital treatment has been widely used by dentistry through the technology like a panoramic view. As you can see, the wisdom tooth is diagnosed through the X-ray 2D image. Extraction or others can be decided in this process. CT is widely available. Using the three-dimensional images, we can conduct the clinical practice in a more convenient way. Number 43, the impacted tooth. In the 2D image, the exact location is hard to locate, but through CT three-dimensional data, the exact location can be recognized in our clinical practice. Therefore, we could have experienced more comfort and precise clinical practice. These processes can be attributed to the advancement of digital technology. I believe you agree with me. Let's talk about the hardware story, like CAD/CAM. CBCT, the CT machine, is widely used, and it is used widely in dentistry, and a lot of people are taking interest in the scanner. Compared to the impression-taking approach in the past, the 3D data can be acquired immediately using the scanner, and many people show interest in them. Prosthesis used to be made by hand. Now milling machine is used to fabricate the prosthesis. That is done by the milling machine. To increase the strength, to color materials like zirconia or ceramic, curing is done with a furnace. Sintering furnace is used. Only recently, 3D printers began to be used in dentistry as the prices have gone down quite considerably. With the development of the technology, the scope of use 3D printers is expanding from the industrial area to many areas in dentistry. First, let me introduce scanners. The dental scanners should be very precise, that is the absolute requirement, and the scanning should be done quite quickly. The scanning is done in the mouth of a patient. It takes too much time. It is giving too much discomfort clinically to the patient and to the staff. And the head size should be small to scan limited area in a mouth. Let's have a look at the types of intraoral scanners. This is most widely used for patients. Intraoral scanner has two types. Capture type and video type. In the past, capture type scanners were widely used. Such scanners are switching to video type. The difference between the two is capture type means various pictures are taken individually and they are stitched together to form a three-dimensional image. Video type is similar to that one. A lot of data is taken and they are put together, therefore, so the video type is more precise than capture type. Second, the model scanner. In the past, rubber impression taking is used to make a model, and it is scanned by a model scanner. For full arch, this is more precise, and it is a capture type scanner. Recently, a lot of research is going on for face scanners. It is used to scan head, neck, and face to make a 3D image. First, let's look at the intraoral scanner. From the 3 shape, the latest product is Trios 4. Like the existing scanners, it is used quite usefully. For the first time, the color is supported by Trios scanner. With the launching of Trios 4, caries is diagnosed by the scanner. Here, as you can see, caries in the contact area is detected. I believe this can be quite useful clinically. Next, as you scan the mouth of a patient, tongue or buccal mucosa, the unnecessary portions are captured and that can be removed with an AI function. Only the needed portions can be scanned. Such function would be very useful. Lower jaw bite images used to be static. From Trios 4, the 3-dimensional movements can be stored or saved. Therefore, the unique movements of a patient can be reproduced in prosthesis or lab devices. What you see is the model scanner. The model is put into the machine. It is a capture type. The whole model is scanned from the various perspectives to make 3-dimensional data. So to scan a full arch, this approach has very little errors. So the scanner has superb precision. At IDS 2017, 3Shape launched a product combining face scanning and CT. I was really curious, so I let them scan myself. After the scanning, I found the images are much more precise than I thought. There were a lot of discussions how the face scan can be clinically used for denture or ortho treatment, or for prosthesis. We can use it to evaluate the face and we can apply it for treatment planning. So face scan would be necessary for those areas. I still remember that I was surprised at the potentiality of the face scan to be used in various clinical areas. Actually, the images were very clean and I still remember the images, very precise images. At IDS 2019, I was really surprised to see so much improvement of performance of scanners compared to 2 years before. Before, I thought I was questioning whether the scanners can be used intraorally, but in 2019, I could see so many scanners got very precise. Now, Trios 4 has been launched, and you can see a lot of advancement compared to previous functions. So in 2019, I came to realize that digital dentistry is something that is absolutely required for many dental services. I've been talking about the scanners. Now, with the scanned data, how can we produce the ortho devices, appliances, using the data? One of the requirements for production machines is whether they can produce products like dental crowns or dental prostheses, very precise, to be used in dentistry. That's most important. To run such machine in a dental office, the size is very important, so it shouldn't be too bulky. Accuracy, size, cost are the most important things to produce prosthesis or lab devices in a dental office. First, CAD-CAM. It refers to NC or CNC milling machines. It uses a subtractive approach. That means zirconia crown or all ceramic the laminates are cut away, the subtractive CAD/CAM. 3D printers, that's the additive manufacturing to produce prostheses that is introduced quite a lot these days. First, CNC machines. In the past, we used to use the lathing machine. It's similar to that. CNC is widely used, but up until quite recently, NC machine was pretty much used. The difference between those two machines, NC has a controller, as you can see in the picture. There's something like a typewriter. OMR card in paper or plastic is inserted. So how many millimeters should be cut away is entered in to control the milling machine. Further, computer functions are incorporated in CNC machine, from where to where, which tool is to be used to cut how many millimeters. That is how it is controlled for CNC machine, which is the most popular one. OSTEM produces dental milling machine. If you look at here, there are some characteristics. There are many different types and approaches. First, 4-axis or 5-axis, wet method or dry method. In terms of the materials, is it in the form of a disc or a squared block? So depending on those, machines are classified, or in terms of the materials to be processed. Performance or types of machines can be classified. First, 4-axis, the tool for the processing. The burr moves in 3 axes, so the tool moves in 3 axes, and the material is moving 360 degrees. That's another axis, therefore 4 axes in total. Thus, it is called a 4-axis machine. And the 5-axis machine, on top of the 4 axes, one more moving direction is added through a hinge, so it moves more freely. Therefore, many parts can be milled in more precise way. So there's one more axis, and it is called 5-axis milling machine, wet or dry milling. Here, depending on the strength or characteristics of the material, it is classified. First, the zirconia block. It is like chalk, so it is not very strong. Without water spraying, precise milling can be done. But here, for metal milling, without oil or water spraying, heat will be generated and the precise milling cannot be done. Therefore, there are wet or dry milling. Let's go to 3D printers. The first 3D printer type is FDM, thermoplastic resin. The filaments are pulled in, and in the extruder, heat is applied and the filaments are melt. Through the extruder, it is coming out to make an instrument or crown or a guide. Actually, the one guide is printed with the FDM method. The precision is quite excellent. Various toys or low-priced products can be printed in the industry or at home. And this system is something we need to take a note. The most widely used dental 3D printer is based on resin, which is quite widely used in dental offices. So there are three types: SLA, DLP, and LCD. And we'd better remember those three names. First, SLA printer. Laser beam is emitted to cure the resin and make an output. Galvanometer is a moving reflector. Laser is reflected from there. Laser is emitted to cure the resin to make the printing output. Second, DLP 3D printer. It is like a beam projector used in a seminar. It is the same mechanism as the beam projector. One plane is irradiated layer by layer. The form is made. This is the most widely used form in dental offices. LCD monitor is used at home and at workplaces a lot. LCD type 3D printers. The LCD printers using the LCD panels are widely used in dental offices. The advantage of the LCD printer over the two previous printers, it has less distortions. From the center of the beam, if you go further from the center, distortions can occur, which is the disadvantage of the previous two printers. In the case of LCD printers, from the LCD display, it prints directly in 1:1 ratio. So it has a great advantage over the previous two. But a lot of heat generation is one disadvantage. So the resin can be overcured, or because of the heat, LCD has a short life. You need to consider the advantages and disadvantages, and you need to select the most appropriate printer in your dental office to approach one more step closer to the digital dentistry. Polyjet printer. Let me introduce it. Like for clear aligners, it can be used for mass production of those. It is very precise. It was popular in the past, but the disadvantage is it is very expensive, so the popularity has gone down. At the top, nozzle and the UV lamp are moving. From the nozzle, materials are sprayed. The sprayed material is immediately cured by an UV lamp. It can be used for mass production, so it can print very fast. And you need to pay attention to this type of printer as well. We talked about resin printers quite a lot. One more material used a lot in dental offices is the metal materials. So there has been a lot of discussion whether 3D printing can be used for metal printing from the past. Laser is used in the industry to print metal powder. It is adopted and used in dental offices. As you can see, the mechanism, the metal powder on the bed is rolled over in a consistent thickness. Laser is emitted over it to melt the powder and then filled up by the roller again repeatedly. RPD frame PFM caps can be produced using this SLS printer, and clinically the precision is good enough. So let's summarize the digital manufacturing. The subtractive cutting CAD/CAM. And 3D printer, the additive manufacturing are the two major categories. Let's move on to the CAD/CAM software. The CAD software exists for prosthodontic CAD, orthodontic CAD, and implant planning CAD. These are three major ones. And CAM for milling machine and for 3D printing, which is getting popular these days. The CAD program software is for designing. CAM below is using the 3D STL file so that 3D printer or milling machines are instructed what tools to be used, how the cutting will be done. So it is like an operator for a machine. First, prosthodontic CAD from 3Shape, Dental Manager, and ExoCAD software. They can cover inlay, crown, implant, prosthesis, and denture. So the software is used for all the designs. Let me introduce orthodontic CAD from several companies. 3Shape and Maestro products are used a lot. The characteristics of the product is that it has the model setup function, which is very important. In the past, the model was set up by cutting a tooth continuously, but now digitally with just the mouth, the setup can be made very easily and conveniently and fast. So this is a breakthrough in the orthodontic area. With the setup data, clear aligners can be fabricated. For indirect bonding bracket positioning, the function can be used. Currently, Awesom's One Guide or guided surgery is performed by many dentists. In doing the 3D guided surgery, implant positioning and the prosthesis can be simulated using software like Implant Studio. Such implant planning CAD is widely used. Implant Studio from 3Shape and ExoPlan software is used quite a lot. Implant Studio is still the most widely used, as it is the most precise and trustable software, as many people say so. Next, CAM software, the most popular ones, two of them, HyperDent and Millbox CAM. You'd better know these two names. Depending on your preference, proper software can be selected in doing digital dentistry. Next, 3D printers. CAM software for 3D printers is cutting the 3D images layer by layer for printing, and sliced data is delivered to the printer. Therefore, the name is slicing software. To manage such data, CAM for 3D printing, the slicing software is used. This is the standards of 3D digital system to be used in a clinic. The most important one, the system can make very accurate products. Otherwise, the software cannot be incorporated in a dental office. So the accuracy of an oral scanner, milling machine, and 3D printer should be very high. Milling machine or 3D printer or intraoral scanners size should be reasonable so that they can be operated in a dental office. If it is too big or too slow in speed, it's not good for in-clinic situation. Next, in terms of manpower, the adoption of digital system should be helpful. I can say that much. And the operation cost should be low for us to be able to set the digital system in our clinic. So depending on the situation or characteristics of your clinic or depending on your needs, the best and most appropriate machine should be selected among all those available machines. Now, Q&A session. Let's look at the questions that we received. Can oral scanner give very precise impression? 5 or 6 years ago, I started to use the oral scanner. The most frequently asked the questions at that time, is it okay? Is it precise? But what they implied in the question is, it's not precise. Why are you using it? That was the impression. But from a couple of years ago, no one is questioning its precision. And they ask, how much is it? Up to what dental care can you use it? But now they ask, should I use it immediately or can I wait a couple of more years? The precision of the intraoral scanner is incomparable to rubber impression or models. This is more precise. Rubber impression and model impression had inevitable errors. The manual fabrication has errors as well. Therefore, oral scanners has much lower level of errors. That's why I apply it in the clinical situation. Next question, how much model-less approach can be used in a clinic? In our clinic, all impressions, like 98%, is done model-less. Our clinic provides almost all services, including prosthodontics, implants, and orthodontics. For about the last 2 years, we have used the oral scanner for model-less in 50% or more cases. Right now, just except a few cases like RPD, we use model-less in most all of clinical cases. Next, what is the requirement for using model-less? You need to have technical understanding and you need to acquire new skill. Therefore, you need to study new stuff. Based on my experience when I adopted the digital approach, we learned the analog way of doing things. Academic lessons were quite good. Therefore, we have made the advancements based on those, and the digital approach has been developed. And in adopting the digital approach, we need to think a little bit differently. We are used to what we learned before, and if we are not willing to step away from that, it can interfere in adopting the digital approach. I sometimes think if I didn't learn the old way of dentistry and if I started from scratch, maybe I could have adopted the new way faster. So when adopting digital approach, we'd better not use old way of interpreting or evaluating the new approaches. If you forget about the analog way of thinking, I believe we can adopt digital way much faster and better. This has been the first lesson of digital dentistry. Thank you.
첫 번째 시간이었습니다. 감사합니다.